So problem 1, the way this usually works out is the problem will give you a drawing and it'll give you some facts. So here are some facts that were given to us, and there's 3 facts in this problem. So something I'm going to strongly recommend to you is study the facts that are given to you in the problem. They're specific to the problem, and see how they relate in the problem with the given diagram. So for example, fact number 1, we're told that CO is the same as OE. So that means CO, this length, is the same length as OE. So if we had numbers, right, if we said that CO was 5, then OE would also be 5. Now, we didn't give you problems in this, we didn't give you numbers in this problem, but just recognize that these lengths are the same. Fact 2 is telling us that OE is the same length as CE. Okay? Now, you could think about relating fact 2 to fact 1, but we're not going to do that right now. We're just looking at fact 2, and it's that OE and CE are the same lengths. Fact 3 says that NE is the entire length minus the distance from here to here. So this almost should remind you a little bit of the segment addition postulate, which we're going to be using heavily in proofs. The problem is asking us to state which fact we're going to use and which property we're going to use to come to this conclusion. So for part A, we notice that CO is equal to CE. That's not a fact. We're going to prove that fact. Okay. What fact could we use? Well, we're looking at CO, right? Fact 1 has CO. So if I use fact 1, which states that CO equals OE, but I also want CE, and that happens to be in fact 2. So I'm going to use fact 2, which says that OE is equal to CE. Now, if you don't notice something, I'm going to add some letters here just to help you with the properties, right? We're saying that this A is equal to this B, and we're saying that this B is equal to this C. So if A is B, but B is C, according to the transitive property, we say that A would be C. Or in other words, we say that CO equals CE. So work with me here, right? It would be like saying, if I'm tired, then I'm hungry. And if I'm hungry, then I eat. We can come to the conclusion at the end of the day, since they're both the same, we can just jump straight to conclusion, and that's that if I'm tired, then I eat. Because one leads to the other, and then it gives us the conclusion. So we're doing the same thing here. If CO is OE, but OE is CE, according to the transitive property, I could just say the heck with these, because they go in the right order, and I could just say CO equals CE. Now you could also say the substitution property if you wanted to, because that would also be true. But the fact that we have this going in order means that it's going to be transitive property. So you might want to write that note in your left column. Make a distinction between substitution and transitive property. When is it appropriate to use one? When might we use the other one? Okay, you might want to pause and write down those words. The differences between substitution and transitive property. The next one we're going to prove is OE minus ON is NE. Well, that looks like fact 3, so I'm going to write down fact 3. But what happened, I mean, all it did is it flipped it around. So it just mirrored it. It kind of just like switched it around. That's called the symmetric property. The symmetric property is used to flip things around. Okay, so if I have line segment AB, for example, I can also write that as line segment BA. Okay? And that's because of the symmetric property. For part C, so we would have begun with fact 3, which is NE equals OE minus ON. But do you know that the NE is there and the ON is there, but the CE became OE? How come? It's already on your notes. It's already on your page right now. So if you want to pause and think about it, that might be a good idea. Fact 2 says that CE is OE. So instead of CE, I can replace that with OE. Now this is a direct replacement, or in other words, a direct substitution. So we use the substitution property to go ahead and, I horribly spelled that, substitution, whatever, property, to go ahead and get that. So we started with fact 3, but we substituted fact 2 to replace this CE with an OE. Part D is a good one. Let me give you a hint and have you pause and think about this. For part D, you're going to use fact 1. I know, right? Fact 1. So, fact 1 is CO equals OE. But call me crazy. I'm going to go ahead and add OE to both sides. So I'm keeping everything the same, right? So for example, if we take it back to Algebra 1, right, or pre-algebra, and I had this equation, if I wanted to add 8 to both sides, I could do that. It doesn't change the equation at all. It'll still come out to be the same answer. So I can add the same number to both sides just because I can. I can add the same quantity to both sides if I want to. It keeps it balanced. Okay, now that was addition. That's the addition property, not segment addition, just addition. CO plus OE stays that way. But if you recall from algebra, I have OE plus OE. Well, that's 2 OEs. That's not OE squared. Okay, if I had OE times OE, that's OE squared. But if I have OE plus OE, that's 2 OE. If that was too much for you, right? If I multiply, you add the powers. If you add the coefficients. Okay, so they're different. They're different. Finally, part E, Cn equals Cn. Well, that's interesting, right? It's actually not any of the facts. It's based on the drawing. So we look at this right here, and I gave you that hint earlier about the reflexive property. Okay, and that's usually going to be useful when I see triangles in a drawing. So let's show you what this looks like. We have this triangle right here, and we have this triangle right here, and they both happen to share the same side right here. So when we say Cn equals Cn, there is no fact that we're basing it off of at all. It's just based on the drawing. So this is based on the drawing that was given. And the property is the reflexive property. Okay. For your summary, consider this line segment AB. Is AB equal to BA? Why? What property would justify that? Explain.